Good afternoon or evening or morning, depending on when you're watching this video. Today we'll be reviewing lines, so linear equations into variables. And these are all the things we're going to cover. Go ahead and read them over if you'd like. And we'll show examples of all of these things as we go through the lecture. We are using the Precalculus Enhanced with Graphing Utilities text by Sullivan and Sullivan. And why don't we start by warming it up? Pause the movie and do the warm-up. Good luck! Okay, let's see how you did. So we have negative 5x. When we distribute the 2 through, we'll have plus 2 minus 6x is equal to x minus 3. We have like terms with the negative 5x and negative 6x. That will give us negative 11x plus 2 is x minus 3. Subtracting 2 from both sides, we will have negative 11x is equal to x minus 5. Subtracting x from both sides, we'll have negative 12x is negative 5. And finishing off by dividing both sides by negative 12, we will have, I'll just rewrite it up here, we will have x is equal to 5/12. How'd you do? Awesome. All right. Let's see what the rest of the lesson holds for us. First part is reviewing slope. So I brought in a picture of a little staircase here to give us an idea. You see that line right there that represents the slope of the staircase. So each step contains exactly the same horizontal run and the same vertical rise. The ratio of the rise to the run, which is called the slope, is actually a numerical measure of the steepness of the staircase. Right? Obviously, you don't want the staircase to be too steep, or when it'd be too difficult to ascend. All right, so next step, we have an official definition for slope. So if you have point P equal to x1, y1, and P2, so my apologies, this would be P and Q we're using. This would be our x2, y2, and they are two distinct points, meaning they're not the same point. If the x values are not equal to each other, the slope, which is denoted by m of the non-vertical line L containing these 2 points, is defined by, you're thinking of it as the change in y over the change in x, which is rise over run, which we can actually put as y2 minus y1 over x2 minus x1 for computations. Now, if x1 is equal to x2, the line L is a vertical line, and the slope m of L is undefined, since this results in division by 0. So let's figure out the slope of the line that contains the given points. So in the first one, we would have m equals, so again, it's y2 minus y1 over x2 minus x1. So our slope would be 4 minus 2 over 3 minus 4. So we would have, good, 2 over negative 1, which we would just write as negative 2. So if you'd like, go ahead and pause the movie, try the other two examples, and then check to see how you did. Okay, let's see how you did. So for this slope, we would have m equals 3 minus 1 over, be careful, 2 minus negative 1. So this would give us a result of 2 over 3, and that is our slope. And thirdly, we have m equals 2 minus 0 over 2 minus 2. So we would get 2 over 0, which is division by 0, which is undefined. So in this case, we have an undefined slope, which means we have what kind of line? Good, a vertical line. So when we're dealing with slope and trying to ascertain slope by looking at our graphing calculator, it's very useful to use a square screen. So in the TI-83s and 84s, most of the time in the standard zoom, what you have is you have the rectangular screen. So we want to use the same scale on each axis. And to adapt for that rectangular screen, which gives you a distorted view, if you make the ratio of x to y at 3 to 2, that will help adapt for it. So let's see what we have going on with this. We can do an exploratory problem where we'll be sure and we'll set our window so that we'll have a square screen. There's also a zoom feature that that lets you zoom to square, but let's go ahead and let's just set our own screen. So in this next example, we want to graph on the same axis. We're going to explore slope here. So we're going to graph all of these guys, and we're going to explore how the slope changes. So, getting the graphing calculator. Let me clear this out. And let me go to the window. So let's do, remember, a ratio of 3 to 2. With these values here, I think we'd be able to tell well enough if we did the x values at 6, plus or minus 6, and the y values at, it would have to be plus or minus what? What would give us the equivalent of 3 halves? Good, it would be negative 4 to 4. All right, so in our scales the same, each one is 1 unit. So now let's go and we're going to go ahead and we're going to have 4 equations. So this will be 1/2 times x. This one will just be 1x, so that's going to be a slope of 1. This will be 4 times x. So we're graphing 4 lines, so let's see how it turned out. So this is our, actually this is our second line, the very first line. Where do you think that one is? Good, it's at the x-axis. I just messed up our square scale here. Let's see. Okay, that looks pretty good. So here, this line here, so the first line is on the axis right here. So this is the line y1 equals 0. And then secondly, we have y2, this guy, 1/2 x. So let's see, this one, basically, if we think of, ordered pairs, you'd have an ordered pair at 0, 0, and you'd have, if you plugged in 2 for x, do you see you'd have an ordered pair at 2, 1? So basically, for this line, for every 1 unit of increase, there are 2 units of run. So every 1 unit up means that you have 2 units to the right, and every 1 unit down means you have 2 units to the left, because -1 over -2 is equivalent to +1 over +2. Now the green line, notice that there is no rise. So we have a run going on, right? But we don't have any rise, so that yields a horizontal line. So now let's look at this guy, 1x. So 1x basically means your y values equal your x values. And it cuts through that first and third quadrant. And lastly, if we take a look at this one, y4, we end up with a steeper slope. Do you see that? I certainly wouldn't want to be climbing up this staircase on a regular basis. Right there. Okay, so, and then these were the axes, x and y, and remember this was 6 and -6, this was 4 and -4. And so the ratio of x to y, remember it needs to be 3 to 2, but do you see if you multiplied both sides by 2, you'd have 6 to 4 as equivalent? So that's what happened there. So notice that as your slope gets larger and larger on the positive side, you're going to get a more steep slope. And as it gets closer to 0, you're going to have a less steep slope. Okay, so far? Good. So now let's take a look. We don't have to change too much stuff. We're basically flipping the sign on everything. So here, going back to our graphing calculator and going to our y equals menu, the 0 will stay the same. And then we're going to insert a negative here. So if you do second delete, that gives you your insert key. So we're going to put the negative symbol here. And then we'll want to insert. And do you see the X is blinking, so you know you can insert without deleting it. Right now the cursor's blinking, right? So if I go second insert, the 4 blinks, and that way I know I can insert something. So let's take a look at these graphs. Look what happens. We're going the other direction, right? So the only one that stayed the same was which one? Good, the horizontal line stayed the same. So again, if we go through and if we highlight these, y1 is 0 is the same as it was before. It's this line here. on the axis, the x-axis, and then I think we had done the blue next. So this one is going to be this guy here. So it's the second least steep slope. Thirdly, we had the yellow. So now the x and y values are opposites. And fourthly, we had the steepest slope. And so that was this guy. Okay, so far? Good. So again, this was our scale. This was our y's and our x's. All right, moving on. So what have we discovered? So when the slope of a line is positive, right, do you see as we move from left to right, from left to right, and if you trace the lines, the line moves, good, upward. And with the negative slopes, as we move from left to right again, and we trace one of the graphs, it moves downward. So let's write that in our notes. And what did we find out about when the slope was 0? The line is? Great, horizontal. Okay, moving right along. So here we go. Let's graph the line containing the point P and having the slope M. All right, so we're going to now use slope to make the picture of our graphs. I'm just going to use the standard scale on these. This is already a square grid, so you don't need to worry about that. So we're given, the given point is that 2, 1. So I'll do it in blue. 2, 1 is the given point. Using slope, if we do this in green, the slope is 4. So you can write 4 as either 4 over 1, or you could write 4 as negative 4 over negative 1. So I'll do the first additional point using the positive. So we'd go 1, 2, 3, 4 up and right to the right by 1 unit. And that gives us the ordered pair 6, 2. Now if I go down from the given point, we'd have down 4, right? I'd have 1, 2, 3, 4, and then I'd move 1 to the left. And that gives me the ordered pair -3. Whoops. Actually, that would be, I have them reversed. I apologize. Miss Gracie's making up her own math today. What was my mistake? Do you see here, I went up 4 from 1. So that gave me my y value is 5. I went right by 1 from x equal 2, so I'd be at 3, 5. So now let's go down here. When I went down 4 and 1 to the left, I ended up being at the ordered pair 1, -3. So down 4 from 1 is -3, and left 1 unit from 2 is +1. So then, when we make the picture of our line, the nice thing about graphing this way is you can make as many points as you need, right? 1, 2, 3, 4, 1, in order to in order to get the correct graph of your line, of course, it helps to have a straight edge as well. So it's going to look something like that. So we actually found more points, but we labeled 2 of them that we found. So go ahead and pause the movie and try the next one and see how you do. Okay, let's see how you did. So for this one, we have a slope of -2/5. So you could think of this as -2 over +5 or +2 over -5 to get our other 2 points. That's one way to do it. So our given ordered pair was at 1, 3. So here is our given ordered pair. So now I'll do the other 2 points. So I'm going to do -2 over +5 first. So that would mean I went down 2 and then 1, 2, 3, 4, 5 to the right. So down 2 from 3 takes me to 1, and then 5 to the right of 1 takes me to 6. So the ordered pair 6, 1 is an additional point on the line. Now if I use the other slope, I'd be going up 2 from 1, and then 1, 2, 3, 4, 5 to the left. So this ordered pair is going to give me, so up 2 from 3 is 5, and then 5 to the left of 1 is -4. So then we would graph the picture of this line. Uh-oh. And it's going to look something like this. Okay. And let me write this one nicer so it's not being crossed out in any way. Oh no. Hopefully it won't cross out my line. Okay, this was 1, 3. All right. So, equation of a vertical line. A vertical line is an equation of the form of x equals a, where a is the x-intercept. So you just have to kind of stick this in your brain. It's very deceptive. It's one of those so easy it's hard kind of things. So, for example, if you were graphing the line, x equals 3, we would go 1, 2, 3. This would be the x-intercept, so we'd be at 3, 0. Let me move that over because we'll be doing a vertical line. This is 3, 0, and the line would go like that. So this is the line x equals 3. Okay. And this is the intercept. That looks a little weird. This is the name of the line, x equals 3. All right. Now, the point slope form of the line is really useful. I use it a lot in my calculus class. So you might want to learn it if you're going to take me for calculus. So an equation of a non-vertical line with slope m that contains the point x1, y1, where that's a point you know, is actually going to be y minus y1 is your slope times x minus x1. And it comes from the fact that, you know, if you have your slope m, and that's equal to y, instead of having x2, y2, we'll leave it as xy so it can vary. So we'd have y minus y1 over x minus x1. And if you cleared the fraction by multiplying by x minus x1, so this would divide out, we would have, let me go ahead and switch these, we would have m times x minus x1 after commuting those factors is equal to y minus y1. And then if I switch the sides of the equation, I have the point slope form of the line. Right? So if you're given, if you're able to find the slope, or if you're given the slope and you have an ordered pair that is not the y-intercept, then this is the best format to use to find an equation of the line. So an equation of a horizontal line, if you take that equation that, I just gave you, y minus y1 is the slope times x minus x1, and we've decided before that the slope of a horizontal line is 0 because there is no rise. Well, 0 times anything's going to give you 0, so you would get y minus y1 is 0, which gives you y is equal to y1. It's more commonly given in the form of y equals b, where b is a constant, and b represents the y-coordinate of the y-intercept. That's a crazy looking bee. Sorry. Here we are. Okay, so let's do it. We've been given two ordered pairs, so the graph, of course, is going to be super easy. We'll just use our standard scale again. And, how do you graph a line if you know 2 points? You plot the 2 points. So we have 1, 2, 3, 4, 5, -1. And we have 1, 2, 3, 4, 5, 6 to the left and 8 up. So this is -6, 8, and this is 5, -1. And then we just connect that line, or these points rather, to make the line. And you've got your graph that looks like that. Now check it out. You could actually just get your slope from the line itself. Do you see that you're going down 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's down 9. And then we're going to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So right 11. So the slope using the graph is down 9, we do -9, right 11 is +11, so the slope is -9/11. Or if you prefer to use the equation, you would just say m equals 8 minus -1 over -6 minus 5. The slope will be 9 over -11, which is just -9/11. So using the point slope form of the line, we can make an equation of the line. So we'll have y minus y1 is the slope times x minus x1. Now here's the trick. You can use whatever ordered pair you want. So I'm just going to use 5, -1. So what I'm saying is x1, y1 is 5, -1. And our slope we said was -9/11. So finishing, we'll have y minus -1 is the slope, -9/11 times x minus 5. So making it a little more pretty, y plus 1 is -9/11 times x minus 5. And that is the point slope form. Okay, so slope-intercept form. So the slope-intercept form means that what if the y-intercept, the ordered pair for the y-intercept was 0, b. So if you plug that in, y minus y1, so y1 is going to be b, is the slope times x minus x1, but x1 is 0. So y minus b equals m times x. And if you isolate y by adding b to both sides, you get y equals mx plus b. So that is indeed the formula. And this is a nice one because you can exactly see what the slope and y-intercept of the line are, and it makes it very easy for graphing as well as other applications. So here we go. Do you see that the first graph is already, or the first equation is already given in that format? So if I think of it as, remember that's the slope-intercept form is y equals mx plus b. So the m here is going to be what? Good. 5, and b is positive 2. So this was m, and b is positive 2. So what does that tell us? Well, again, we'll just use that standard scale. That's easy enough. So x and y and we should be able to use it for this guy as well. So here we can plot the y-intercept first. Okay, so we'll plot the y-intercept. Remember, that's the ordered pair 0, 2, because b was 2, and that is the y-coordinate of the y-intercept. And then using the slope, we can get as many points as we need. So the slope is 5. So we can either go 1, 2, 3, 4, 5 up and 1 to the right to get the second point. Or we can go 1, 2, 3, 4, 5 down and 1 to the left. And then you just make the picture of your line. Oh, that's a bit wavy. Let me redo that one. I don't know what my problem is today. My son always says it's my leftiness. Okay, so there we go. Now, what about this one? This one isn't in our format right now, right? So we need to do a little bit of work. So we have this 2x minus 3y is 9. If I subtract 2x from both sides, I get negative 3y is negative 2x plus 9. Now be careful, because when you divide by negative 3, you have to divide both of the terms on the right side by -3. So isolating y, we're going to get positive 2/3 times x, and then minus 9/3, which is -3. So now our slope is what? Good. 2/3. And our y-intercept is good. It's -3, right? Because the formula has a plus, mx plus b, and minus is the same as adding the negative. So let's go ahead and plot the y-intercept, and we'll highlight these things so you can see what corresponded. And then here was our slope. So we have, now we're at 0, 1, 2, -3. And we have a slope of 2/3. So if we go up 2 and to the right 3, we'll have a point here. We could always go down 2 and to the left 3. And then when we make our line, it will look something like this. Okay? How are you feeling so far? I warned you this might be a little long, so. Alrighty, equation of a line in general form. You may have, your authors in your intermediate algebra may have used standard form. Standard form and general form you can think of as the same form. So the equation of a line in general form is ax plus by is equal to c, where a, b, and c are real numbers, and a and b are not both 0. So let's graph this one by using intercepts. Right? So if I let x be 0, y will be -4 times 0 plus 2y is -12. So I would get 2y is -12, and y would be, good, -6. So I'd have the ordered pair 0, -6. Now if I plug in 0 for y and solving for x, I'll have -4x plus 2 times y is -12. Oops, my y was 0. 2 times 0. So -4 times x is -12. Dividing by -4, I get x is +3. So 3, 0 is the x-intercept. All right, here we go. So 0, 3 is here, the x-intercept. And then 0, -6. 1, 2, 3, 4, 5, 6. So 0, -6. 3, 0. Oh, I put that right in the way of where the line's going to be, didn't I? 0. So our graph will look like this. Okay. So now, find equations of parallel lines. When two lines in the plane do not intersect, they're said to be parallel. So, if you have two lines, so what needs to be true about these lines? There's a couple things that need to be true about these lines so that they don't intersect. They have to have the same grade. They have to have the same slope. And don't they have to have different y-intercepts? Because if they had the same y-intercept, they'd be collinear or the same line. So those are the criteria. So two non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. Okay, so show that the lines given by the following equations are parallel. So here, let's just identify the components. We already know which two things need to be present. So if we call this guy line 1 and this guy line 2, do you guys see that line 1 is negative x plus 4? So the slope is good, negative 1, and the y-intercept, the b, is 4. Good. Now line 2, we have to work with a little. If we subtract x from both sides, we get an equivalent equation with a slope of, good, negative 1, and the y-coordinate of the y-intercept b is negative 1. So the slopes are the same, the intercepts are different, so we have shown that the equations are parallel. So L1 and L2 are parallel. And if you wanted, you could call this, I don't want to confuse you with subscript, because we found the slopes were parallel, or slopes were the same rather, and the y-intercepts were different. So these guys are equal, and these guys here are different. Okay? So, perpendicular lines. When two lines intersect at a right angle, which is, 90 degrees, they are said to be perpendicular. Okay? So, if you have, it would look something like this. Whoops. So you have x and y, and you have, say, a line like this, and a line like this, and they meet at right angles. Okay. Okay, so criterion for perpendicular lines. Two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. All right, so show that the lines given by the following equations are perpendicular. So here, if you consider this the first line, the slope, let's call it M1, is what? Good, 1/2, because it's already in slope-intercept form. And what about this one? Very good. M2 would be equal to negative 2. So what we want to check is is m1 times m2, is that equal to -1? So plugging in for m1, we have a half, and m2, we have -2. And we see if that is equal to -1. Well, -1 is equal to -1, so that checks. The lines are perpendicular. So the following examples, and this is a little bit of a long one. we actually have several of these. So this is kind of a whole mishmash of different situations, and you'll be figuring out how to find the equation of the line. So like always, I think it's a great idea for you to try these things yourself. But if you need to follow along with me, that is fine. Okay, so let's see and notice the directions instruct us to use general form and slope-intercept form. But we'll be using point-slope form in order to get to the point where we can look at those other two formats. So we've been given that the slope is 2 and the line contains the point for -3. So we've been given the slope and a point that is not the y-intercept. So let's use y minus y1 is the slope times x minus x1 to get us started. So plugging in -3 for y1, 2 for m, and 4 for x1, we'll have y plus 3 is 2 times x minus 4. So we're going to work with that and get it into the two desired formats. So that's point slope form right here. So to go to general form, and it doesn't really matter what order you do this in, but to go to general form, we would say, let's start here at y plus 3 is 2 times the quantity x minus 4. So what we would like to do is we need to distribute the 2 through, and we'll get 2x minus 8 on the right side. And if we do a couple of things, we want to subtract 2x from both sides and subtract 3 from both sides so that we get the constant alone on the right. So we'll have -2x plus y is equal to -11, and that is our general form. So now if we go to get to slope-intercept form, why don't we take our result from, you can start with any part you want, but we might as well use our general form, and then we just need to isolate y. So we'd be getting the x term back on the other side, and our slope-intercept form will be y equals, we want to do the x term first, and then our constant. Okay, so far? Great. So, what do we have here? It says an undefined slope that contains the point 1/2, 7. What kind of line has an undefined slope? Great, a vertical line. Vertical lines have a slope, an undefined slope. So that tells us that we need to just use the x coordinate here, and we write the line as x equals to 1/2 because the x-intercept would be at great 1/2 comma 0. So believe it or not, that's the equation of that line. And we made this connection here. Undefined slopes mean vertical lines. Okay, so now what have we been given for part C? We've been given the intercepts. So why don't we write that in a more illuminating format? So this means that -4, 0 is a point on the line, and 4, 0, both of these are points on the line. So let's just go ahead and muscle through. We'll find our slope. So m equals 0 minus, oh, I mixed this one, sorry. This would be 0, comma 4, good. So we would have 4 minus 0 over 0 minus -4. So the slope will be equal to, do you see it would be 4 over 4, which is 1? So in our point slope form, we would have, or actually we don't, it would be a lot easier in this case. We've been given the intercept and we have the slope. So we've been given the y-intercept and we have the slope. So we're going to use that information. We're going to use this information, the fact that that's our y-intercept, and this information to make the line. So for slope-intercept form, we'll have y equals mx plus b. So y equals, our slope was 1, so 1x plus 4, good. So y is x plus 4. That is slope-intercept form. And then going over to generate our general form, take y equal to x plus 4, subtract x from both sides, and we'll have -x plus y is equal to 4, and that's our general form. All right, moving right along. We've been given two-ordered pairs, so let's start by finding the slope. So m equals 5 minus 4 over 2 minus -3. So we will have, our slope is 1/5. So y minus y1 is the slope times x minus x1. So I'm going to just pick why don't we do that second ordered pair since there's no negatives. So we'll have y minus 5 is 1/5 times x minus 2. So starting there, I'll go ahead and do our general form. So let's clear this of fractions. So we have that fraction there. So this 5 divides out that, and we'll have 5y minus 25 is equal to x minus 2. So subtracting x from both sides and adding 25 to both sides, we will get -x plus 5y is equal to 23. So that will box our answer. And the slope-intercept form, we'll take the general form, and now we need to add x to both sides, and we will have 5y is x plus 23. Dividing both sides by 5, we will have y is equal to 1/5 times x plus 23/5. And we're done. Oops. All right. How are you doing? Okay, we're getting close to the end of this section. I know it was a bit of a bear. Thank you for your patience. Here we are. Now, these are, a little more complicated. We need to find one that is parallel to a given line and containing a specific point. So parallel lines have the same what? Good. Parallel lines have the same slope. So if we found the slope of this line, right, and used it for our new line, it would turn out being a problem similar to one of the ones we did before. So let's check it out. So this given line, x minus 2y, is -5. If we isolate the y, so we're going to take away x from both sides, and then if we divide by -2 on both sides, do you see we'll get positive 1/2 x, and we'll get plus 5/2. So that was a result of dividing by -2 or multiplying through by -1/2. And so the slope of this line is 1/2. So that is the slope we will use for our new line. And then it just becomes like before. So y minus y1 is the slope times x minus x1. Y minus 1 is 1/2 times x minus -5. So y minus 1 is 1/2 times x plus 5. So now the general form we have y minus 1 is 1/2 times x plus 5. So if we multiply both sides by 2, the 2 and the 1/2 will become 1, and on the left we'll have 2y minus 2. So these guys divide out. So then, subtracting x from both sides and adding 2 to both sides, we will have -x plus 2y is 7. And that's our general form. So now the slope-intercept form. We will just take our result from our general form and add x to both sides. And we will have 2y is x plus 7. Dividing both sides by 2, we will get y equals 1/2 times x plus 7/2, and we're done. So again, that one was a little bit, little bit crazy, but you got it, okay? Okay, perpendicular lines. Now, Perpendicular lines are at a right angle to each other. So what kind of line is this? Y equals 8 is a good horizontal line, right? So what kind of line is perpendicular or forms a right angle to a horizontal line? Awesome, a vertical line. So believe it or not, our answer here is x equals, good, we take the x coordinate in the given point. So if you drew a picture of this one, and if this was 1, 2, 3, 4, 5, 6, 7, 8, so this here is the line that they want us to form a perpendicular line to, and 3, 4 is supposed to be on our line. So 3, 4 is here. We need to make a line that is at right angles to this line. And so it's this vertical line when x is -3, or x is +3. Great. Okay, moving right along. The equations of two lines are given. Determine if the lines are parallel, perpendicular, or neither. So you can sort of just go through your list, right? So here, this guy has a slope. We'll call it M1 is 4. And this slope, M2, is good, -4. So M1 is not equal to M2, right? So that tells us not parallel. Next thing to check is M1 times M2. Is that equal to -1? Well, actually, we'll go vertically here. The first slope was 4. The second slope was -4. When you go to test if that's -1, you definitely get a false statement there. So what does that tell us? Not perpendicular. So we would say for our answer, neither. All right, next up, the first slope is 1/3, good. The second slope is -3. So first up, M1 is definitely not equal to M2, right? So that means they are not parallel. So now to check, is M1 times M2, is that equal to -1? So M1 was 1/3, M2 was -3. We're checking to see if that's equal to -1. -1 sure is -1. So that means these lines are perpendicular. All right, and that wraps up the lesson for section 1.4, and that actually wraps up what we're going to cover from, at this point in time, what we're going to cover from chapter 1. So make sure you review your chapter 1 assignments and go over the chapter 1 practice that I gave on my math lab and hone your skills. Have a fabulous day. Bye.